Hi class, this is Neil, and this is the second video of lesson 5. In this video, we're going to be determining another way that we can think about tangent of theta. All right, so we're going to do what's called a proof here. To prove that this other way of thinking about tangent of theta is in line with what we already know about tangent. So I'm going to write out the following trig ratios. Sine, we know, is opposite over hypotenuse. Cosine, we know, is adjacent over hypotenuse. And tangent, we know, is opposite over adjacent. Okay, so for the second part of this proof, we're going to use our ratio of sine of theta and solve for the opposite side. So we're going to be solving for our O in the equation. So let me just write it out. Sine of theta equals opposite over hypotenuse. So to solve for the opposite side, I'm going to need to multiply both sides by the hypotenuse. This will cancel. Do it to this side as well. And now I have a new equation for opposite. So opposite is equal to the hypotenuse times sine of theta. All right, so we're going to do the same thing now for cosine of theta. So starting with my equation, I've got cosine of theta is equal to adjacent over hypotenuse. Solving for the adjacent side, I would multiply both sides by the hypotenuse. And I'm left with the equation adjacent is equal to hypotenuse times cosine of theta. All right, so finally we're told rewrite the ratio of tangent of theta from the beginning, so from right here, using our new definitions of adjacent and opposite. All right, so tangent of theta we originally saw was opposite over adjacent. We're going to just substitute in what we solved opposite to be. So opposite is the same as the hypotenuse times sine of theta. Adjacent is the same thing as the hypotenuse times cosine of theta. Now if we simplify this, you should notice that we've got an h over an h. Those will just cancel out. So now we have a new trig what's called a new trig identity. And that is that tangent of theta is the same as whatever the sine value is of the angle over the cosine value of the angle. And this will be important for us in the problems that follow. All right, so let's take a look at what we have for these two practice problems. So for question 1, determine the value of tangent of theta given that sine of theta equals 0.866 and cosine of theta equals 0.5. Well, we're going to use our identity. Tangent of theta equals sine of theta over cosine of theta. And I'm just going to substitute in my values there. So I'll have tangent of theta equals 0.866 over, my apologies, 0.866 over 0.5. You tell me what that equals. For the challenge, think about if sine is positive and cosine is positive, what quadrant could we be in? Okay, so for number 2, determine the value of sine of theta given that cosine of theta is 6 over 10 and tangent of theta is negative 8 over 6. Okay, so one thing we could think about here is sine is the same as opposite over hypotenuse. Cosine is the same thing as adjacent over hypotenuse. And tangent is the same thing as opposite over adjacent. Well, given what we have in this problem, what does 6 represent? Well, that represents my adjacent side. What does that 10 represent there? Yep, that represents my hypotenuse. Now, thinking back to our ratios and our new identity, tangent of theta is the same as sine of theta over cosine of theta. So we should be focused in on our numerator here. All right, so that gets you started with 1 and 2. I'll see you in the next video.